Hello everyone. In this video, we are going to discuss about link power budget and rise time budget. And these are the two important analysis which decide the performance of any optical fiber link. So, how we will calculate link power budget and rise time budget? Link power budget is also known as power budget, and rise time budget is known as bandwidth budget. So, we are considering we are calculating this link power budget for the point to point fiber optical lines, and this is the diagram of simple point to point link connection. Here this is encoder modulator optical channel through which the signal is transmitted. This is the detector and this is the decoder. So here we can say this is the transmitter and this is the receiving end and this is the optical fiber link. So now we have to calculate link power budget. So how we will going to calculate this link power budget? So for this, optical power loss model is designed, or here you can see the diagram of optical power loss model. Here two terminal and one is transmitter, another one is a receiver, and these are the connectors, and here LC denotes the losses occur at connector. So all the components in this link which are contributing to the loss, we have to calculate the losses due to these components. So the loss occur at the connector end is given by IC, and the losses occur at the splices denoted by LSP, and alpha F denotes the losses occur inside the optical fiber. So these are the three different type of losses due to three different component, due to connector, due to splices, and due to optical fiber. So all these three losses together give the rough estimate of total loss occurring in the system. And link power margin also consider the loss due to aging and temperature fluctuation. And the total optical power loss is given by connector loss plus splicing loss plus fiber attenuation plus system margin. So connector loss, 2LC, here two connectors are there, splicing losses and system margin. And here L denotes the transmission distance, up the distance between this transmitter and receiver. So by this formula, we can calculate the total optical power loss. In and now we see one example how to calculate the link power budget. So here in this example, we have to design an optical fiber link transmitting data at 15 MB per second over distance of 4 km with the BER of 10 to the power minus 9. So here in earlier video we have discussed about different parameters that is to be decided before the designing of the system. So now here we have to select the optical source, optical detector and the optical fiber. So we have selected LED as an optical source of 820 nanometer because the distance between transmitter and receiver is 4 kilometer only. This is very short distance, so 820 nanometer LED is used and it generates power of 10 decibel, 10 dBm optical power. And now we have selecting pin diode as an optical detector having minus 50 dB sensitivity. So now we have to calculate the and which type of optical fiber we have selected. We have selected step index multimode fiber having bandwidth length product. Here we are calculating bandwidth length product. So these are the parameters that we have selected, and there may be few examples where these parameters are may be given. If given, then that use those parameter. If not given, then you can select the parameter. And now here no losses are given, so we are assuming the losses occurring at different components. So generally splicing losses is around in this range. Connector losses, system margin loss, fiber attenuation loss. So we have assumed all these parameters. These parameters is not given in the question. So we have assumed these parameters. Now we have to calculate actual loss. So it's very simple. By using this formula, we have just put the value in the given formula and we got the total loss around 35 dB. Now what we have to do, we have to identify what is the maximum allowable system loss. So that is given by optical source output power. This is given minus 10 dB and optical receiver sensitivity is minus 50. So when we calculate, then we will get 40 dB. So this is the actual loss and this is the permissible loss. So if the actual loss of the system within the system is less than the allowable loss, then system is functional. So with these parameters, we have designed one optical fiber link having total system loss 35 dB, which is less than the total permissible loss. So these parameters, these assumptions are true, and with these assumptions, we can design our optical fiber link. So this is all about the calculation, how you will calculate the link power budget. And in next video, few more examples are given over here. We will discuss all these examples in next video. Thank you.